For the next set of videos here, you may want to have your popcorn handy. We'll be talking about processing food, process of nutrition, and then dealing with the waste as well. Animals are heterotrophs. We get our energy by eating molecules that have been made by other living things as our primary source there. And so how we get our nutrition, that's important for our survival, and a lot of the interaction between different living things. So very important part of looking at ecosystems above the organism level as well. We need all those basic types of molecules we talked about back in the beginning of class. We need proteins, we need lipids, we need carbohydrates, nucleic acids, we need vitamins and minerals. Now, exactly what types of vitamins and minerals? You've got different things need different amounts. For example, we build our skeletons with calcium phosphate. We need a lot of calcium and a lot of phosphate to do that. Not very many non-vertebrates use calcium phosphate though. So they won't need as much, at least of the phosphate, maybe of the calcium, depending on what they use. A lot of things use calcium carbonate. Malnutrition, then, no surprise, is a significant problem. Whether you're getting not enough or you're getting too much of stuff. Either one is not the right amount and causes various health problems. Okay, so food, there are a number of things we have to do. You have to get it. So feeding, one thing, identify what is food. Nope, that's a mineral. And then once you identify food, well, you need to get it and get it into you. And there are many ways of doing this. For example, the long beak here on the weevil is specially built for it being able to make a hole and reach into a seed and get at the more nutritious material inside. Or the panda bear here grabbing bamboo, stuffing it in its mouth, chewing that up. The snake here looks rather ambitious in trying to swallow the lizard, but it's trying there. Okay, so the ingestion process itself is basically actually eating, getting the food started inside you. You then need to digest it. Break up the food as it was going in, and this includes both making smaller pieces and also the chemical breakdown from the complex molecules likely present in the food already into molecules you can actually use. For example, starches, polysaccharide, made of lots and lots and lots of sugar molecules all attached together. We need to break those up. We don't need starch, and we're not plants. We don't even store stuff as starch. Glycogen, but not starch. And then make the sugar molecules that we can actually use from the starch. Proteins, likewise, we need to break those up into the amino acids, and then we can use those amino acids to rearrange and build into the proteins that we need. So you have both mechanical and chemical breakup of food as part of digestion. Once we have broken the food down into small molecules, the body can absorb that, taking in those. And so from being inside the digestive system for the actual digestion, those bits need to move through the walls of the digestive system and into the body. So we can use those, whether it's for energy as fuel or building blocks to help make things. And of course we store some of it as well. Not everything we eat is something we can actually use in the body. And so we also have getting rid of whatever waste is left over. Options on feeding. We have herbivores also referred to as primary consumers, because they're the first step up on the food chain from the producers. These are things that eat plants or algae. Carnivores are secondary or potentially tertiary, higher up. They're eating herbivores or potentially other carnivores. This is especially true in water. In land, you tend not to have too many things that are actually eating other carnivores, although some do. But in water, you can go quite a few steps up a food chain, each one eating things until finally you get down to the stuff that was eating the algae. Omnivores, like humans, are often eating both plant and animal material. And there are a variety of styles of things. Specialized scavengers, eating stuff that's already dead. On the one hand, if something's already dead, it's not going to run away, and it's not going to fight you. So it's pretty easy to catch something that's already dead. But something that's dead, it's maybe kind of rotten. That's more work for your immune system. Less work for your catching, but more in dealing with the stuff. Some other options here. Suspension feeding is filtering small particles from the water. Often you have kind of a network of tentacles, maybe even a mucus net, and small things in the water, say little tiny one-celled algae, things like that, get stuck and captured. Detrivores are things that are eating usually tiny bits and pieces from either stuff that's dead, often plant rather than animal, or bits of waste, things like that. And also the bacteria, fungi, things like that are growing on these bits. An earthworm is a familiar detrivore. It's going through the dirt and typically either digesting stuff it can find in the dirt, or earthworms will also, say, eat bits of plant stuff that's on the ground surface. The ones that come up to the top of the ground will grab bits of leaves and other fragments of stuff from the ground surface. Deposit feeding, likewise, is basically eating sediment, sand or mud. Now this may be very picky, only eating the stuff that is definitely rich in nutrients, well, for mud, or they may just swallow lots and lots of stuff and let the digestive system sort it out. What are some advantages and disadvantages of these different approaches? If you're an herbivore, finding plants is usually not hard to do. Most habitats have plenty of plants or algae around, as long as you're not so deep in the ocean that it's dark, or extreme climates. And plants are pretty easy to catch. They don't run away. On the other hand, we're not plants. Plants are very different. For one thing, they can't run away. They tend to have more chemical and physical defense. And so they are much more work for the digestive system to break down and get the nutrients needed there. And so there are various approaches. One simply is to keep stuff in your digestive system for a long time. Herbivores characteristically have much longer intestines than carnivores, keeping food in there for a long period of time. Another thing that can help is get somebody to help you. Symbiosis. A number of herbivores have a variety of bacteria and protists living inside the gut that help to digest things. So, for example, ruminants, things like cows and sheep and camels that chew the cud, what they are doing, they have bitten and chewed on things to break it up. Goes into part of the stomach for a little while, and then when the animal's got a chance to rest, it actually brings that back up into the mouth to chew some more, break it down, spend more time, and it goes into a part of the stomach that has quite a lot of different types of bacteria and protists in there that can secrete enzymes to help break down the relatively tough plant material there. Another approach, if at first you didn't succeed in getting nutrients out of your food, try again. This approach is used by rabbits, for example. Coprophagy, eating the poop. It's been through the digestive system one time, it's had some breaking down, some bacteria with it. Put that through the digestive system another time, and you've got another chance at getting the nutrients out of it. Carnivore, on the other hand, it's trying to digest animals. Well, it is an animal. So turning animal into more animal is less hard. It's much easier to digest animal material typically than plant. So they typically have a relatively short digestive tract. On the other hand, animals often can move, can try to escape, may have other defenses. And so you've got the challenge of catching your food more so for the carnivore. Omnivore, well, if you'll eat anything, it's not too hard to find a meal. At the same time, if you're eating some of this, some of that, you're less specialized, and so won't be able to compete quite as well with a specialized carnivore or herbivore that is really good at eating a particular thing. Detrivore, well, there's plenty of bits and pieces of old leaves and stuff like that around. It's abundant, and it's not going to run away. No trouble trying to catch the stuff. But those bits and pieces of dead leaves and whatever other remains are out there, that's the leftovers, the stuff that other things either didn't bother eating or they already ate and it went all the way through their digestive system without getting broken down. So the stuff that detrivores are eating is typically less nutritious, harder to digest. More work for the digestive system, but not so much work for trying to obtain the food. Again, we'll look at a series from relatively simple to more complex systems. Some types of animals, such as sponges, tapeworms, a number of animals that are symbiotic, do not have a specialized digestive system. Sponges, pretty simple, they've got water circulating through, and so just the tiny bits they catch, an individual cell can digest the bacterium or absorb chemicals and pass it on to other cells. No special system needed there. Tapeworm. Well, where's the tapeworm live? It's in your digestive system. It doesn't have to have a digestive system of its own. You've done all the work. It just sits there absorbing what you've already digested. So no special system there. But most animals require some sort of system to be digesting their food.